Hello everyone. In this video, I'm going to explain the very basic and very important concept to understand calculus in 10 plus 11, in 10 plus 1 and 10 plus 2. That is either 11th or 12th. The topic name is intervals. So intervals will play a very good role in understanding of concept, solving of inequations, etc. So what are these intervals? See, sometimes if if we want to list out a finite number of elements, then we can list out them in set roster form. In set roster. So if there are infinite number of elements, then it is difficult to write in set roster form, means just writing the elements individually, like set of 1, 2, 3, 4, etc. So now what I am going to do is, suppose how to represent the numbers between -1 and 2, between -1 and 2. So these concepts will be explained very clearly with simple diagrams. Please uh, like and share this video and subscribe. So here you see, I have taken a real line. I have explained in basic inequalities. Real line, you can say it is a horizontal line from -infinity to infinity. In the middle, 0 will be there. So the numbers which are right side of 0 are positive real numbers. The numbers which are left side of 0 are negative real numbers. Now you see, I will explain through an example. After that, I'll write the definition. For example, see, x takes x is a variable. So x takes values less than 1. That is, so we know that how to write that less than, greater than, less than or equal to, greater than or equal to x less than 1. Right? Then how do we represent this x less than 1 in another format? You can say in set form. So here you keep 1. So we want that x is less than 1. So x is less than 1 means simply you can say the numbers which are left side of 1. So this we will write that x belongs to, see, -infinity to up to 1, -infinity to up to 1. So this we call open interval. This is called open bracket. Open bracket. So here x does not take value 1, but x assumes all the values less than 1. I will take another example. For example, 1 less than or -1 less than x less than 2. How do we represent that x lies between -1 and 2 in interval form? So this we will write same as like this. Okay. This is -1 to 2. Well, -1 to 2 means this is -1 and this is 2. So we have to take the values between -1 and 2. Right? Means we have to list out all the numbers between -1 and 2. So this we will write in another way. X belongs to -1 to 2. So the meaning of this statement is that x lies between -1 and 2. The meaning of x belongs to -1 comma 2. This is a open bracket. So this we call as open interval. This is nothing but open interval of -1 comma 2. Because in coordinate geometry, just the same representation indicates the coordinates of a point. So we must specify that open interval. Similarly, suppose if we include any numbers, let us take -2 less than or equal to x less than or equal to 3. How do we represent this kind of notation? X lies between -2 and 3, including -2 and 3. Means x can assume -2 as well as x can assume 3 and any number between -2 and 3. So here you can see this is -2 and this is 3. So x assumes all the values between -2 to 3, including the numbers, -2 to 3. So whenever this less than or equal to is there, or equal to say, or equal to is given, you just put very dark. Here you see this is open. So we represent that this expression as, see, we have a different kind of inequality. Here we have strict inequality. For strict inequality, we use that open bracket. For non-strict inequality, we use square bracket. This implies x belongs to closed -2 to 3. So this is known as closed interval. Closed interval of a comma b. Of here -2 comma 3. So whenever this less than or equal to non-strict inequality comes, we have to use that a square bracket. For strict inequality, use open bracket. Wherever strict inequality comes, there you have to use open bracket. Right side, here right side strict inequality, so right side open bracket. Left side strict inequality, so left side open bracket. Here less than or equal to non-strict inequality, so we have to use a closed bracket. Now, I am going to define these intervals in a systematic way. Well, so here you see that open interval denoted by like this open bracket. So set of x such that a is less than x less than b, where x is a real number, denoted by, so a less than x less than b is denoted by simply x belongs to open interval a comma b. Here endpoints are not included. So I'll write here, you see, they are not included. So I'll just circle and here b between a and b. So x takes values between a and b. X can take any value between a and b, between this. Okay. Now you see, so therefore I can write that a less than x less than b. We can write that x belongs to open interval a comma b. So I told you that this bracket is known as a open interval. This is known as a open bracket. This is open bracket, or you can say parenthesis, open bracket. Whenever this strict inequality comes, you have to use this. So for example, here I will give you an example also. Easily you can understand -1 less than x less than 2. So this is same as of expressing in the interval form that x belongs to, you start with the left hand value -1, you keep -1 open bracket and 2 open bracket. So read as open interval -1 comma 2. Okay. So this is nothing but this is read as open interval a comma b. Open interval of a comma b. Interval of a comma b. So now what is meant by open interval of a comma b? If x lies between two quantities a and b, then we write x belongs to open bracket, comma left hand point, comma right hand point, and again open bracket, that is closed one. One is the open, another one is closed. So this is the left hand number, this is the right hand number. Now similarly, coming to this closed interval, here you see, if you want, I'll give here a few more examples. -3/2 less than x less than 0. So this we write that x belongs to -3/2 to 0. So the meaning of this statement is x can take any value which strictly lies between -3/2 to 0. Means x can take -1/2, -0.9, -1 point. See, it is more than -1.5. So -0.8, -0.6, -0. Like this, you can take any number strictly between that -3/2 to 0. Now, coming here, closed interval. So closed interval means we denote it by closed bracket a comma b. So when do we write this? See, if x lies between a and b, x lies between a and b, then we write that it is same as of x belongs to closed interval a comma b. Here I am writing a less than or equal to x less than or equal to b. So this is same as of x belongs to, we read this square bracket as a closed interval of a comma b. So here I'll plot, this is a. So because a is included, so we keep a dark dot, this is a, and here a dark dot, this is b, and any number between these two is the closed interval. Up to here, like this, up to here. So between a and b. For example, these are very simple concepts. Once you understand, you can solve the questions. For example, -3 less than or equal to x less than or equal to 2. So how do we represent this? X belongs to closed interval. Whenever this less than non-strict inequality comes, you have to use this bracket. -3 to read as x belongs to closed interval -3 to 2. So here I have discussed one is open interval, Another one is a closed bracket. Now there are intervals that one side open, other side is closed. The first one is both sides open. The second one is both sides closed. Now the third one is one side open and one side closed. Those are known as semi-intervals. Semi-open interval or semi-closed interval. See here. A is less than, X less than or equal to B. So how do we write this? X belongs to, here you see, this is strict inequality. So you have to write open interval. This is corresponding to this. And here non-strict inequality. So I have to write closed bracket. A, comma, B. Means X takes the values more than A and less than or equal to B means either less than B or maybe equal to B. Maybe equal to B. So here this is A. So A is open and this is B. So it is closed. So F assumes all values between A and B. Okay. But it will not assume the A, but it will assume B and all the values between A and B. Similarly, we have that A is less than or equal to X and less than B. This is known as left closed, right open. So we write X belongs to left closed, right open. So this is left closed, and right open bracket, right open. So these are the known as semi-open or semi-closed intervals, simply semi-intervals. So here I'll give you an example. Okay, here E is less than, X less than or equal to I. So we write this, that X belongs to, see, the left side is open, so open bracket E, whereas right side is pi, closed bracket. Here X can take any value between E equal to 2.718 approximately, and pi value is approximately 3.14. So X can assume any value between E and pi. Similarly, minus 1 by 2 less than or equal to X less than, if you get some pi by 3, you take any number. So how do we represent this? So here X belongs to left side is closed. So left side is closed, minus 1 by 2, comma, open interval 5 by 3. So once again I'm telling X lies between A and B, that is open interval. So X assumes any value between A and B. If we include A and B, then it becomes closed interval. If one endpoint is included and other endpoint is not included, then it is called a semi-open interval. Right. Here both ends are finite values. Here both ends are finite values. Even I did not specify, but still A and B are real numbers, because we are whenever we are plotting numbers on real line, definitely they must be real numbers. So here I can write for the namesake that let A comma B belongs to R, and of course, A is less than B. So now, one end is indefinite, means interval starts from one point and there is no end, right? So such intervals, how do we denote? Here you see. See here, x greater than A. X greater than A, right? So it starts from A. It starts from A, but A is open, right? More than A means you have to take to the right side, like this, more than. This is infinite. So the meaning of this is x belongs to. It starts from A. A is open. And infinity is also open. Because infinity is not a number. It is a symbol to represent a huge number in which no one can imagine how large it is. No one can imagine how large it is. So whoever give a number, that infinity is greater than your number. So that means it is a symbol to represent a very large quantity, positive quantity. Now, x greater than or equal to A. X greater than or equal. Which means that now x assumes A or any value more than A. X assumes A or any value more than A. So somebody else has more than 100 crores. Right? So that means x greater than somebody has either 100 crores or more than 100 crores. So then x greater than or equal to 100. Like that, see, x belongs to here. I told you that whenever this non-strict inequality comes, you have to use closed bracket A to infinity. So here A, this is A, right? So we have to start from here and goes up to infinity. Up to infinity. Right. Next one is that x less than A. X less than A. Now, the before one is x greater than A. So now, here right hand is limited. Right hand is limited, whereas left hand has no limit. Has no limit. So here I take A. This is A. Right? And we have to take values between minus infinity to A. Minus infinity to A. Minus infinity to A. See, easily you can observe from this diagram. So x belongs to minus infinity to A. Here A is open because strict inequality is there. And minus infinity is also not a number. It is a symbol to represent the least value on the real line. The least value on the real line. And x less than or equal to A is represented by same as of before one. X belongs to, it is closed, of course, minus infinity to A closed. Because here x is less than or equal to A. Finally, this is also very, very important, that how do we represent that entire real line in an interval form. Entire real line in an interval form. So x lies between minus infinity to infinity. Okay. So this way represent that x belongs to R. So another way of expressing that x is a real number, which means that x lies between minus infinity to infinity. X assumes all real values. Then we write x lies between minus infinity to infinity. These are all you can take if and only. Means this implies this is correct. Both ways you can write. When interval is given, you can write in inequality form. When inequality is given, you can write in interval form. So now, how do we write that R plus? R plus means only positive real numbers. So positive real numbers means only 0 to infinity. This implies X, or you can say X belongs to R plus. We can write X belongs to 0 to infinity. And R minus. R minus means only negative real numbers. So minus infinity to 0. Or whenever we say that X belongs to R minus, the meaning of this statement is nothing but X assumes only negative real numbers. So minus infinity to 0. Well, and this is R naught. R naught means except non-zero real. Except 0. Except 0. So R naught equal to, we write minus infinity to infinity minus set 0. Or you can say R plus union R minus. So I'll give you a few examples. Easily you can understand. One, express the following in interval form. So if I give x greater than 1, then x greater than 1 means it starts from 1. It starts from 1 and there is no end. It goes up to infinity. It goes up to infinity. So the meaning of this statement is x belongs to 1 to infinity. Okay. I need not to draw a real line every time. I hope you understand very well that this is. So here it is 0. Okay. So here it is 1. So we want to take that more than 1. More than 1 means you just keep like this, goes up to infinity, more than 1. Similarly, suppose x is greater than or equal to minus 2, which means that x starts from minus 2, it goes up to minus infinity. So here strict inequality is not there. So we have to use a closed bracket, that is closed minus 2 to infinity. Well, okay. And next one is, for example, x less than minus 3 by 2. Or you can say like this, that x plus 3 by 2 less than 0. Right? So what is the meaning of this x plus 3 by 2 less than 0? X less than, sending this plus 3 by 2 that side, it becomes minus 3 by 2. So x is less than minus 3 by 2. I think now you can understand that the main importance of intervals. So we'll write in interval form that minus infinity, it starts from, goes up to minus 3 by 2. So this is the minus 3 by 2, you can say, okay, like this, minus infinity, right? This is corresponding to this one. Do not confuse. Like this, in order to solve a linear inequalities, this is known as a solving of linear inequalities. I'll give you one more example. For example, 2x plus 5 less than or equal to 0. Whatever inequality is given, that you have to write exactly. So here 2x is less than or equal to minus 5. Now divide by 2. because 2 is a positive quantity. 2 is a positive quantity. So inequality will remain same. X less than or equal to minus 5 by 2. Here I am writing that A is less than B and C is positive. Then A by C is also less than B by C. Whenever we are multiplying a positive quantity to the inequality or divide, the inequality remains same, right? So this means that x belongs to minus infinity to minus 5 by 2 closed. Minus 5 by 2 closed. Consider another example. Another example. X plus 3 or 2x plus 3 lies between minus 1 and 2. Okay, express the following in interval form, or you can say solve the following. Okay, so this I'll write. This implies, you see, subtract this 3 from total inequality. So minus 1 minus 3 less than or equal to 2x. Okay, we are subtracting 3 plus 3 minus 3 less than or equal to 2 minus 3. Okay, this implies so we are subtracting 3 from the entire inequality. So we get minus 4 less than 2x less than or equal to minus 1. Now divide by 2. Okay, divide by 2. So you will get minus 4 by 2 less than or equal to x less than or equal to minus 1 by 2. So this is known as solving of linear inequations. Minus 2 less than or equal to x less than or equal to minus 1 by 2. So we can write in interval form, this is x belongs to, here we have a non-strict inequality on both ends. So we write x belongs to closed interval minus 2 to minus 1 by 2. In another separate video, I'll solve a few questions based on these intervals because this video becomes little lengthy. So in separate video, I'll solve a few more questions, how to solve linear equations, how to express intervals, etc. So let us finish this video by discussing intersection and the union of two or more intervals. Intersection and union. Intersection means which is common to both. Union means club those two or two or more intervals. You have to club them. You have to consider everything. So here you see, to find union intersection of two or more intervals, what we do. For example, here you see, let A is less than x less than B. Okay, so this implies then what we can say is that x belongs to open A comma B. Well, okay, and x belongs to C comma D. C comma D. Okay, where you must know the order of A, B, C, D. Where A is okay less than, C is less than, B is less than. Suppose like this it is given. We want to find out the intersection of these two. The intersection of these two, right? So, one. What is the intersection of these two? Open interval a comma b, intersection, open interval c comma d. How do we write? Right? Okay. So for this, what we have to do, you just draw a line. You just draw a line, real line, like this. It is very simple to understand. Okay. Plot the real numbers according to the order. So here A, and here C, okay, and here B, and here D, right? So now first one is between A and B, between A and B. So first one is between A and B, like this. The second one is between C and D, between C and D, like this, between C and D. Intersection means we have to take the common values. You have to take the common values. Observe here, these are the common values. From C to D are the common values. You have to take that overlapping of two lines. Overlapping of two lines. So this is nothing but this is equal to C to B. You have to take the common. You have to take the common lines. Wherever you find the common lines, from that boundary you have to consider. So C to B values are common to A, open interval A comma B and open interval C comma D. Then how do we write that union? Suppose we want to write union like this, union of C comma D. We want to write union. So what is the meaning of union? Union of two intervals means you start from left hand and go to right hand, right? So here this is the left hand and this is the right hand. So you write totally the A2. Here in this case, overlapping is there. Here overlapping is there. So I can say instead of like this, after putting on real line, you begin with A. And you see, you go up to D. So this is open interval A comma. It is not necessary that every time you will have a common values. You will have a common values. Now I'll explain by giving a simple example. You see, what is minus 1 by 2 to 3? Okay, intersection. I will take that 0 to 4. I want to solve this. What is the intersection of these two? In next video, you will understand why do we take intersection, why do we take union, etc. So now you see, you draw a real line. You draw a real line. Okay. So you plot the numbers. See here, this is minus 1 by 2. All are open and this is 3. And here 0. And here 4. Okay. The first one is between minus 1 by 2 to 3. The second one is 0 to 4. Now easily you can understand that what is the common? This is the common portion. From where to where? It is 0 to 3 is the common portion. Right. It is not necessary that every time they may have common values. I'll give another example. minus 1 by 2 to 0, intersection 1 to 2. If I assume like this. See minus 1 by 2 to 0. Here you see minus 1 by 2 to 0 and 1 to 2. There is no intersection. So you write this as a empty set. Easily you can understand. There is no common, there are no common values, or there is no common interval, right? This is minus 1 by 2. Okay. And minus 1 by 2 to 0. Minus 1 by 2 to 0. And 1 to 2. 1 to 2. You see, is there any common interval overlapping? There is nothing overlapping, right? So for the same one, if I ask, minus 1 by 2 to 0, union 1 to 2. Okay. So if I ask this one, this is equal to, if I ask this one, what is the union of these two intervals? See, these intervals are disjoint intervals, right? So these are the disjoint intervals. Disjoint intervals means there is no common at all. Disjoint intervals. When nothing is common of two or more intervals, then they are known as disjoint intervals. So if you want to ask what is the union of these two intervals, there is nothing is there. Just this only the union. Because we have to write them separately. Because this is separate, this is separate. So you keep the union between the intervals. When do we write in single interval? For example, you see, the above one is minus 1 by 2 to 0 union. If I ask that minus 1 by 2 to 3, this one, union 0 to 4. If I ask like this, see, this is the left hand point and this is the right hand point. There is no break at all. There is no break at all. So you take minus 1 by 2 to 4. There is no break at all. Here there is a gap between 0 to 1. So this I can write open minus 1 by 2 to 2 minus you subtract that 0 to 1. You subtract 0 to 1. Closed 0 to 1. Both are same. So this is the union of two intervals. Like that, you can take union of two or more intervals, 5 intervals. Of course, you need not uh, do the problems on more than 3 intervals. Maximum in every problem, you can find hardly 3 intervals. So intersection of 3 intervals, union of 3 intervals, etc. So in the next video, I'll explain a few questions based on solving of linear inequations and advantage of this intersection and union of intervals. And finally, I'll give one more example. I didn't give any example based on one semi-open interval and open interval. For example, minus 1 by 2 to 0 closed union open. Okay, this is 3. Okay, 0 to 4 closed, like this. See here, the common interval is 0 to 3. The common interval is 0 to 3. So here 0 is open. Okay, and 3 is closed. So 3 is closed. That's it. So according to the given situation, you have to take the intervals.